Welcome to Byte-Sized Tech, your weekend edition of what's trending in tech and gadgets. So if this week had a theme, I think it would have to be the battle for computational control. I mean, we saw some huge players making massive corporate bets.
Yeah, absolutely. High-stakes stuff.
And then there were new regulatory controls, deciding what kind of knowledge can even cross borders, plus a kind of quiet revolution happening, maybe right in your headphones. We're diving into the 5 biggest stories you really need to know to stay ahead of the curve.
That's right. And, our sources this week, they really paint this picture of a tech landscape that's just defined by these astronomical costs on one hand and this relentless drive for efficiency on the other. So we'll dig into the raw horsepower competition in AI chips, the incredible amount of money needed just to play the game. Meta's big gamble really highlights that.
Yeah, we have to talk about Meta.
Definitely. And then we'll look at the government countermoves, the regulations, and finally, how sound quality is making this interesting comeback in consumer audio.
Okay, let's start right there with the hardware. Because for ages, really, NVIDIA's dominance in enterprise AI, it felt almost total, right?
Pretty much undisputed, yeah.
But now, it looks like we're seeing a serious challenger step up. AMD's new chip, the Instinct MI355X. It seems like it's aimed right at NVIDIA's weak spot.
It really does look like a calculated strike. And it's not just about, overall speed. It's about performance on these massive, really complex AI models. We're seeing data already showing the MI355X is, well, very competitive against NVIDIA's top chip, the B200. There was one test, Llama 370B pre-training, using FP8 precision.
Okay, hold on. Let's quickly unpack that term FP8 precision. For folks listening who maybe aren't GPU architects, what does using FP8 actually do when you're training these huge models?
Good question. So FP8 stands for 8-bit floating point. See, when you're running these gigantic AI models, memory is everything. You have to be super efficient. By cutting the numerical precision down from, say, 16-bit or 32-bit down to 8-bit, you basically have the memory needed for all the model's weights and activations.
Right, less data per number.
Exactly. So you can cram much larger models onto the same piece of hardware. Now, there is a tiny trade-off in accuracy sometimes, but for training these big models, it's a standard trick, really crucial.
Got it. So AMD is competitive on speed, using these standard tricks, but the sources say the real advantage, the knockout punch maybe, is memory. What have they done with the MI355X?
It's just sheer capacity. The MI355X packs 288 gigabytes of high bandwidth memory, HBM.
288 gigs, wow.
Yeah, and this massive memory pool, it allows for something AMD is calling single GPU execution.
Single GPU execution. Sounds good, sounds fast. But, thinking about the bigger picture, NVIDIA has always had this massive advantage with its software with CUA. Is AMD maybe sacrificing some of that developer ecosystem, that compatibility, just to win on this one hardware spec, the memory?
Well, that's the million-dollar question, isn't it? That's the real friction point. NVIDIA's CUA is still, a huge advantage, a big moat around their business. But this hardware edge that AMD is pushing, it could be absolutely critical for certain kinds of models, like take Llama 3.1405B. That thing is enormous.
405 billion parameters.
Right. So for NVIDIA's B200 to even run that model, it has to use a technique called tensor parallelism.
Okay, tensor parallelism. Can you break it down a bit?
Sure. Basically, it's model splitting. You take that massive model, the 405 billion parameters, and you chop up its mathematical bits, the tensors, across multiple GPUs, let's say 8 of them.
Okay, divide and conquer.
Kind of. But the problem is those 8 chips then have to constantly talk to each other. They're shuffling data back and forth over the connections between them to process everything. And that communication, that's the slow part. It's inefficient.
The interconnect bottleneck. And AMD gets around that.
Exactly. With that huge 288 GB HBM pool, the MI355X can actually fit the entire Llama 3.1405B model onto just one single GPU.
The whole thing on one chip.
The whole thing, yeah. So you completely skip that slow data transfer between chips. And the performance gain is huge. Our sources were citing like a 1.35x to almost 1.6x lead in offline inference speed for that specific model compared to the B200 cluster. For businesses using this, it means one MI355X could efficiently run 2 simultaneous really heavy chat sessions, like 128,000 tokens each, with a 70 billion parameter model. That's way more users per chip.
That technical edge sounds massive. But it leads us right into our next story, because even efficient chips cost an absolute fortune, and the financial scale of this AI hardware race is just mind-boggling. Which brings us to Meta. and their multi-billion-dollar AI gamble.
Oh, yeah. This one definitely sent some shockwaves through the market. So
Yeah.
Meta recently increased its capital spending forecast for 2025. We're talking $70 to $72 billion.
$70 billion just for next year's spending.
Yeah. And Zuckerberg himself said 2026 would be notably larger. There are reports swirling around suggesting they might be planning up to, get this, $600 billion in AI infrastructure spending over just the next 3 years.
$600 billion.
Hmm.
It's almost hard to even comprehend that number. I mean, that's bigger than the entire market cap of a lot of huge established tech companies. And the market reaction was pretty swift and brutal, wasn't it?
Oh, immediate.
Yeah.
The stock plunged 12%, just like that. Wiped out around $200 billion in market value. Investors are clearly jittery.
Yeah, you can see why.
They're worried it's the metaverse all over again, pouring tens, now potentially hundreds of billions into this huge long-term bet without a clear, immediate way to make that money back. The big worry is monetization.
But wait, other big tech companies, Amazon, for instance, they're also spending tens of billions on AI stuff. Why are investors singling out Meta? Why treat their spending as so much riskier?
It really boils down to the fundamental business models. Amazon has this, well, structural advantage. They get 2 bites at the apple with their infrastructure spending.
How so?
First, they use all that AI compute internally, right, to make their retail operations smoother, their ads better targeted, all that. But second, and this is the key difference, they turn around and sell access to that same infrastructure to thousands of other companies through AWS, Amazon Web Services.
Right. So AWS basically subsidizes their own internal AI development and acts as this huge revenue stream on its own.
Precisely. They build it, they use it, and they sell it. Meta, though, they don't really sell cloud infrastructure services at that kind of scale, so that potential $600 billion, it's almost entirely a cost. It has to be justified purely by making their own stuff better, maybe slightly better ad targeting, or by inventing entirely new products down the line that don't even exist yet.
So there's no external customer paying for the infrastructure build-out. That makes it a much higher stakes gamble.
A significantly higher risk proposition for investors, yeah.
Which leads perfectly into our third story, because it makes Meta's other big move seem even stranger. They're spending all these billions building models like Llama and then just giving them away, open source. Why pile on the financial risk by not even trying to sell the thing directly?
Right. If you're spending potentially $600 billion, why are you giving the core intelligence away for free? It seems counterintuitive, but the challenge for Meta is, unlike, say, Microsoft or Google, they're fundamentally an ad company, right? They don't have this massive engine for selling commercial software licenses. And because Llama is free, venture capital firms, the people funding startups, they're pretty hesitant to pour money into companies built entirely on a foundation that anybody can get for free, especially now that other strong open source models like DeepSeek are popping up and sometimes even beating Llama on certain tasks.
Okay, so direct sales are tricky, the VC angle is weak.
Right.
What's the strategic endgame here? Why do it?
It looks like high-level game theory. There's this concept called commoditizing the complement.
Commoditizing the complement. Okay.
Yeah. Meta's goal probably isn't to make money directly from selling Llama access. The real goal seems to be preventing rivals, think Google, think OpenAI, from completely owning the next fundamental layer of computing, the AI platform layer, like the next operating system. By making powerful base models free and easily accessible, Meta makes it much harder for competitors to charge huge premiums for their foundational models. It limits the potential profit pool for everyone building those base layers.
Okay, so it's a massive, incredibly expensive defensive play. Spend billions to keep the foundational AI layer from becoming a toll booth owned by someone else, which could eventually threaten Meta's main ad business way down the line.
That seems to be the logic. They're essentially paying a huge amount to ensure they don't lose the platform war, even if it means they don't directly win the model selling business itself.
Fascinating. Okay, from the financial platform war, let's pivot now pretty sharply to the global geopolitical side of things. Our fourth story is about this new phase of tech control. We're moving beyond just controlling the physical chips to trying to control the knowledge those chips create.
Yeah, this is a really significant escalation in regulation. The U.S. Commerce Department has rolled out these sweeping new rules. They kick in January 2025, restricting exports of advanced computer chips. That's sort of expected. But the really novel part, the big change, is a new control specifically covering AI model weights.
Model weights, so the actual learned parameters, the intelligence inside the AI model.
Exactly. The core knowledge the AI has learned. These are now under a new classification, ECCN 4E091.
ECCN 4E091. Okay, for listeners, ECCN is Export Control Classification Number. What does this specific control actually do? What does it target?
It sets a very high bar. It imposes a global licensing requirement, meaning you need permission to export these anywhere. And importantly, there's a presumption of denial for the most powerful AI models.
Presumption of denial, meaning the default answer is no.
Right, and most powerful here is defined by the amount of computing power used to train them. Specifically, models trained using $10 computational operations or more.
10 to the power of 26. That sounds like an astronomically large number. Can you give us some context? How big is that, really?
Yeah, it's hard to grasp, but think of it like this. That 10-byte threshold is roughly equivalent to models about 100 times the size or complexity of something like Llama 370B, which is already a very large model.
Okay, so 100 times Llama 370B. We're talking truly massive, cutting-edge AI.
Exactly. It's designed specifically to put a fence around that absolute bleeding-edge frontier AI research. The stated goal is to prevent malicious actors from using that top-tier AI capability for things like developing weapons of mass destruction or for advanced military uses.
The intention seems clear. Containment of the most powerful AI. But our sources point out something really interesting, an unintended consequence, perhaps. You called it the sanctions paradox. Does trying to lock down this power actually end up boosting innovation elsewhere?
It really seems to paradoxically accelerate it, yeah. Constraint forces innovation. Chinese companies, for example, who were already cut off from buying the absolute fastest U.S. chips and systems due to earlier rules.
Right, they couldn't just buy the best stuff off the shelf.
Exactly. So they couldn't just throw more and more hardware at the problem. They were forced to get incredibly good at optimization, at software efficiency, squeezing every last drop of performance out of the hardware they could get.
So a kind of forced discipline leading to breakthroughs.
You could say that. And this necessity has led to some remarkable gains in efficiency. We're seeing Chinese models now, like DeepSeek R1, that are reportedly 10 to 20 times cheaper to actually run than competing models like GPT-4o from OpenAI.
10 to 20 times cheaper. That's huge.
Oh, it's a massive difference. And this makes these highly efficient, low-cost Chinese open-source models incredibly attractive, especially to countries in the global south, developing economies. This low cost and accessibility, it starts creating these pathways, these dependencies that actually favor the Chinese AI ecosystem in the long run. The whole competitive game starts shifting maybe from who has the most money to spend towards who uses their resources most efficiently.
That point about efficiency potentially beating sheer scale or capital. That's a really powerful idea to track. Okay, let's shift gears completely now. Let's leave the data centers and the geopolitics behind and dive into the consumer world for our fifth and final story. It's about the hi-fi revival. It seems like after years of convenience first, maybe consumers are starting to prioritize audio quality again.
They definitely seem to be. And the market numbers back it up. The overall hi-fi system market is projected to hit about $17.5 billion by 2025. A lot of that growth is driven by, wireless connectivity, smart home stuff integrating. But the really interesting part is this push for quality. Hi-res audio is genuinely gaining momentum.
Okay, high-res audio, when we talk about that, we're not just saying sounds good. There's a technical definition, right?
Absolutely. High-res audio means digital music files that go beyond standard CD quality. CD quality is 16-bit depth and a 44.1 kilohertz sample rate. High-res goes much higher, up to, say, 24-bit and 192 kilohertz. Basically more data, which translates to richer sound, more dynamic range, more detail.
Can you give us a practical example of that difference in data?
Sure. Think about streaming services. Some services that really focus on this quality, like Qobuz, they can stream music at byte rates up to like 9,400 kilobits per second.
Okay, over 9,000 kilobits per second.
Yeah. Compare that to Spotify's standard maximum quality setting, which is 320 kilobits per second.
Wow. 320 versus over 9,000, that really puts the data difference into perspective. And no wonder people are investing in better headphones and speakers to actually hear that.
Exactly.
So if the market for better sound is growing, how are the traditional hi-fi companies coping? The ones who used to sell, the big separate amplifier, tuner, CD player, that whole stack. That seems less common now.
Yeah, the classic component stack is definitely less central. They've mostly shifted towards two main survival strategies, it seems. The first is pivoting towards these more integrated ecosystems, often involving subscriptions. Think about something like Rune, which is software that acts like a central brain for your music library, connecting different hardware brands, streaming services. The value shifts from the individual box to the seamless experience you subscribe to.
Got it. So selling the whole integrated platform experience, not just the gear. What's the second strategy?
just moving way upmarket, really embracing a luxury brand identity, selling beautiful, expensive, high-performance gear where the price tag itself kind of shields them from the race to the bottom we see with, like, cheap Bluetooth speakers.
Right.
They sell prestige, craftsmanship, enduring quality.
Makes sense. Two different ways to find a profitable niche. But you did mention one potential snag, a constraint that affects this whole growing audio market and really anyone who listens to music a lot.
Yeah, it's a serious point. Despite all the cool tech, the fact that we have all these personal audio devices now and people are using them for longer periods, it's raising real public health concerns about noise-induced hearing impairment, especially among younger listeners. That potential health impact, it's a kind of persistent headwind the whole industry has to navigate carefully.
That's a really important point to end on. So this week, wow, we covered a lot.
Yeah.
From AMD making a play against NVIDIA focusing on memory.
Right, that efficiency angle.
To Meta's absolutely massive spending gamble, just throwing capital at the problem.
Yeah, the sheer scale approach.
Then the U.S. government trying to control AI knowledge itself, setting that incredibly high 10i threshold.
And the paradox that might create, boosting efficiency elsewhere.
And finally, this interesting return to quality in consumer audio, even with health considerations.
It really does highlight that central tension we saw across different stories, doesn't it? You have AMD trying to win with memory efficiency. You have Meta betting billions on just scale, on raw capital. Then the sanctions paradox seems to force Chinese firms to innovate through efficiency, making their stuff cheaper globally. So the big question to ponder, maybe this weekend, is who ultimately wins this AI race? Will it be the players who maximize efficiency maybe because they have to? Or will it just be the ones who can raise and deploy the most staggering amounts of capital? Efficiency versus scale.
That is a fascinating question to think about. Definitely something to mull over. That's it for this week. If you enjoyed the episode, like, comment, share, and subscribe for more fun tech discussions.